In section 1.3, we're going to start by introducing a few new concepts that build off of what we did in section 1.2. So the first idea will be what's known as a measure of spread. A measure of spread can be best thought of in contrast to a measure of center. In 1.2, we talked about two measures of center, the mean and the median. A measure of spread, unlike a measure of center, which describes kind of the middle of the data set, a measure of spread describes how far apart values in the data set are. Do they tend to clump together, or are they spread out a lot? And so a few examples of measures of spread are things that we'll see like the interquartile range, or IQR, which describes where the middle half of the data lies, or a better way of saying it, how far apart the middle half of the data is from each other. And then also what's known as the standard deviation, which is something that will become really important later in the course. And the standard deviation, it's a bit hard to define exactly what it is, but in some loose sense, it describes on average how far away are data values from the mean. We'll then introduce the notion of an outlier. An outlier is just any value that doesn't really fit in the pattern of the rest of the data set. And we'll give a specific criteria for determining which values in data sets are outliers. We'll then look at a new type of graph that you may have seen before that's known as a box plot, often called a box and whiskers plot, which is a graph that represents the maximum values, the minimum values, as well as the quartiles and median, and also shows whether there are any outliers. So really quickly, we can look at this graph of, this is a box plot of the data set of serial box weights that I showed in the section 1.2 introduction. So this graph is telling us that the maximum value is right around 22, the median's right around 20, the middle half falls between this line and this line, and then this circle down here indicates that this low value, which it's actually 4 low values in this data set, there are 4 values that are 16, those are all outliers. They don't really fit in the pattern of the rest of the data set. Then finally, what we're going to do is we're going to take everything together that we've done in sections 1.1 through 1.3, and we're going to describe a data set fully. And this will consist of, first of all, just saying what the numbers mean. So that is, what is the sample, what is the variable? So in the case of the set of serial box weights, I would say, well, this is a sample of 100 serial boxes, and where the numbers represent their weights in ounces. And then we'd give a measure of center. So we might say, oh, well, the median serial box weight is 20 ounces. We'd give some measure of spread. So we might say what the interquartile range is or what the standard deviation is. We'd describe the shape of the distribution. If you recall from last time, we said that the distribution was left skewed. And then we'd also report any unusual features. In particular, we're often interested in outliers. So as I mentioned, this specific data set has 4 outliers that are all the same value. That value is 16. And so what we've really done in this section is we've completed what we did in sections 1.1 and 1.2, so that what we can do is we can take a data set like this set of 100 values of serial box weights, and instead of just being a list of 100 numbers, we can put context to it and describe it, right? So we can say where those numbers come from. We can describe different measures, tell us kind of where they're centered at and how far apart they are. And then we can say something about the shape and any other features of the data set. So that's what we're going to do in section 1.3.